right, ladies and gentlemen, so today we're going to be getting into chapter 9, and we're going to be starting and talking about these things that are called quadratic functions. And a quadratic function is nonlinear, so these are not going to be our straight lines, and they have a degree of 2. So we worked on factoring these types of problems. Now we're going to be getting into graphing and other ways that we can solve them. Our standard form, which we've talked about before, remember f of x just means that it's a function. It can be replaced with y. But we have ax squared plus bx plus c. And we're going to be using those a, b's, and c's to do different things. The parabola is the shape of the graph, of a quadratic graph. It's going to be U-shaped, and it can go up or down. We're also going to talk a lot about something called an axis of symmetry, which is a center line that divides the parabola into 2 equal parts. Vertex is also called the turning point, and we're going to talk about that as well. And then we can have either a minimum or a maximum. If it goes up, if it's opening up, that vertex is a minimum. It's your lowest point. If it's going down, so let me just kind of draw a little picture here. So your minimum would be right about there. If it's going the other way, then that vertex would be called a maximum. It's the highest point of a graph. All right, so let's get into what we're going to do with these here. So we have a couple, this is just some general information, but this right here is very important. If I want to find the axis of symmetry, first of all, it's always going to be an equation x equals. And you can't really tell, it got a little bit blended here, but it's negative b over 2a. That's going to tell me where is that line that kind of divides the parabola in half. I can use this number to then find the turning point, because that gives me the x value, and then I can find y. And we're going to be talking about a bunch of different ways that we can graph these and solve them. So when I'm doing this, here they want me to use a table of values to graph y equals 3x squared plus 6x minus 4. Well, I have to know where to start my with my table of values. So I'm actually going to first start by finding my axis of symmetry. So I'm going to do x equals negative b over 2a. And the b and the a come from my equation. B is the one that's with the x term, so this is going to be negative 6 over 2 times a is your leading coefficient. So there's your a, there's your b. So 2 times 3. So negative 6 over 6, which is negative 1. That's the kind of the center line. That's going to be where the turning point is. So I'm going to put negative 1 in the middle, and then I'm going to go backwards and forwards. So these are now the values that I'm going to use for x. I'm going to put those into my calculator. So this is 3 times negative 3 squared plus 6 times negative 3 minus 4. Remember, when you have a negative base, you have to make sure you put it in parentheses. But I'm just going to save some time, I'm just going to fill in the values that you should get when you do this. And you should notice, if you have the axis of symmetry, that the pattern then repeats itself. 5, negative 4, negative 7, negative 4, 5. And that should always happen. Now we're just going to take and put it on our graph. So I have negative 3, 5, negative 2, negative 4, 1, 2, 3, 4, negative 1, negative 5, 0, negative 4, and 1, 5. And when you do that, again, you're going to see that you get this nice U shape. We're going to put arrows on the end of it. So down here, this is the vertex. It's also then the minimum because it's the lowest point of the graph. It wanted us to state the domain and range. Domain, remember, are your x values. So my domain is going to be all reals. Right? There's no distinction on that. My range, which is my y's, well, your range is going to depend on what where your vertex is. So my range, y has to be greater than or equal to, this is down here at, I guess I put that in the wrong spot. I'm sorry. This should be down a little bit more at negative 7. There we go. So y has to be greater than or equal to negative 7 because that's your vertex. All right, let's see what we got going on here on the next page. Find the vertex, the equation of the axis of symmetry, and the y-intercept of each graph. So your vertex is going to be your lowest point, so that's right here. So the vertex for this is 0, negative, I'm sorry, screwed that up, I apologize. The vertex is negative 1, 0. This then is your axis of symmetry, x equals negative 1. Your y-intercept is just what it says. Where does it intersect the y-axis? And it intersects the y-axis at 0, 1. So this is your vertex. This is the y-intercept. All right, over here, here is my vertex, which is the point 2, 3, which means this is the axis of symmetry, x equals 2. My y-intercept is where it crosses the y-axis, which is at 0, negative 1. Vertex, y-intercept. Okay, so you should be able to get those from the graph. Now we're going to use some of our equation stuff. So our axis of symmetry is always negative b over 2a. Right? You need to have that memorized. That's not going to be given to you. So for this equation, here's your A, here's your B, here's your C. So it might help you to go through and label those. So I'm going to have negative 4 over 2 times 2. So that's negative 4 over 4, which is negative 1. Your vertex, to get your vertex, you're going to put this value into the equation to see what y is. So I'm actually going to do 2 times negative 1 squared plus 4 times negative 1 minus 3. And again, I'm going to throw that all into my calculator, and you're going to get negative 5. So my vertex is the point negative 1, negative 5. Negative 1 came from the axis of symmetry. The negative 5 came from me putting that value in. Your y-intercept is your C. So your y-intercept is going to be 0, negative 3, because they want it written as a point. So we don't go left or right. We only go to up or down, and that was your C. All right, let's try another one over here. Oh my gosh. Actually, I'm going to leave this one for you, and then we'll check it over in class, because we still have a bunch more notes to do. So you guys try B, and then we'll talk about it. We'll go over the answer in class. All right, let's go over here. So now we want to be able to look at and determine how you can tell if it is a minimum or a maximum. Is it going to go open up or is it going to open down? And that all depends on what your A is. If your A is positive, it's going to go up. If it's negative, it's going to go down. All right, so let's see what we want to do here. Consider f of x equals negative x squared minus 4x plus 6. Determine whether the function has a minimum or a maximum value. Because this is negative, this is going to be a max, because it's going to go kind of like that. State the minimum or maximum value of the function. That is your vertex. And just like we did over in the other problems, I have to start by finding my axis of symmetry. So negative b over 2a. Again, here's a, b, c. So we're going to have, let's see, the negative of a negative 4 is positive 4. And 2 times negative 2, so 4 over negative 4, which is negative 1. Now I have to put that into my problem to see what we're going to get for, for my y value. So if I put negative 1 in, so that's going to be negative 2 times negative 1 squared minus 4 times negative 1, plus 6. So this is your x, this is going to be the y, and when I put that in my calculator, I got 8. So my maximum value is the point negative 1, 8. State the domain and range. Your domain for these should always be all reals. Now, my range, because this is a maximum, it means y has to be less than or equal to the value that I got here, 8. All right. So let's see. Again, I'm going to leave number 5 for you guys to try, and we'll talk about it in class. Let's go down here and see what else they want to do. So now they want us to try graphing this without a table. So you're going to find the equation of the axis of symmetry first. So again, here's A, B, C. And is this the same one from above? No, sorry. Okay. So that's going to give me my axis of symmetry, negative b over 2a. You have to have that memorized. So this is going to be negative 2 over 2 times negative 2. So negative 2 over negative 4, which is 1/2. All right, so that's my axis of symmetry. Then we have to find the vertex. The vertex is when we take this and put it into our equation to figure out what y is going to be. So I'm going to have negative 2 times 1/2 plus 2 times 1/2 minus 1. And when I did that, I got negative 1/2. So I know that my vertex, my turning point, is at 1/2, negative 1/2. Find the y-intercept. Your y-intercept is C. So my y-intercept is going to be 0, negative 1. So now we're going to kind of put that information on our graph. So I know that I'm going to actually label this and kind of make it a little bit bigger so it's a little easier. So I'm going to go up by halves. And then, so this would be negative 1/2. And I know it's very messy. I apologize for that. So I know that my turning point is at 1/2, negative 1/2. So that's 1/2, negative 1/2 is right here. I know that that's going to be the axis of symmetry. I know that it's going to intersect here at 0, negative 1, which is down here. I know that it's going to go down, and if this is the axis of symmetry, then I also have a point over here on the exact opposite side of that. So my graph goes like this, and I know it goes down because it is a negative 2. So negative means it opens down. I think we might have time for one more. I'm sorry, this is such a long video. This just goes through and compares our different types of functions that we've looked at. We've looked at linear functions, and I know this is kind of sloppy and hard to read. We've looked at exponential functions, which are curves. Now we're looking at quadratics, which are parabolas. And this just goes through and gives some more information. Let's see what they want us to do here. Emilio is competing in the javelin throw. The height of the javelin can be modeled by the equation, where y represents the height and feet of the javelin after x seconds. Graph the path of the javelin. So I want to do the same type of thing here. So I'm going to start by finding my axis of symmetry. So x equals negative b over 2a, a, b, c. So I'm going to have negative 64 over negative 32, which is 2. I'm going to put this into my equation to figure out what y is. So we're going to have negative 16 times 2 squared plus 64 times 2 plus 6. I'll admit I have not gotten that one done yet. So let me put that into my calculator here. Oh, we're going to run out of time. I'm going to pause this so that I can get this done, and then I'll come back and show you. Okay, so I went through and finished solving that. So you got 70, which means this is your vertex. 270, and again, you can double check that. I know that it curves down because A is a negative number. So I used, and then my y-intercept was at 0.6. So I counted up by tens. It's a little hard to see that, and then I kind of had to approximate. But here's your axis of symmetry. So I knew if I had a point here, I have to have one on the other side of that line, and that's how I connected these. At what height is the javelin thrown? That's your y-intercept, right? That's your starting value for these. So it was thrown from a height of 6 feet. It goes up because that's your times 0. All right, we're going to definitely work on this in class, but any questions, please bring them, but you have to know those two formulas, x equals negative b over 2a, and that your y-intercept is c. Have a good night.